Hi, everyone. I'm Lance Thornton. I'm the Principal Product Manager for Character Animation and Rigging at Autodesk. And today I'm going to be talking about MotionMaker. And also, I have a co-presenter here. Etienne, would you like to introduce yourself?
Hi everyone, Etienne Allard, lead developer on MotionMaker.
Before we jump into the presentation, first I'd like to show you this video that Griffin Animation Studios did, primarily using MotionMaker. So that's great work by Griffin Animation Studios, who did this project for us. They did it in about 5 weeks from start to finish, which is pretty fast. That includes blocking, layout, the actual animation, and of course effects and rendering. Um, and the data point there is that if they had not had access to MotionMaker, it probably would have taken about 3 times as long to do the animation. And a lot of the time saving was really relating to if there was direction to change the paths or how the character moved, the speed and so forth. Then those would be very difficult to react to without the generative system. So let's jump into what MotionMaker is. First, before I get into the details, I do need to show this safe harbor statement. It's really just we're not making a promise of delivery of new features if we talk about anything that's future looking. Okay, so MotionMaker, what is it? Well, it's a generative animation assistant for character animation. And the idea is that it saves time. You could use this for layout, of course, previs workflows. You could use it for your blocking passive animation. And in some cases, it might be good enough for certain types of actions. And of course, we see an application in crowds as well, just really speed up the whole process. And let's just kind of, compare that sort of traditional. If I were going to make a walk cycle, this is a time lapse of creating that. So you're setting keys, perhaps you're matching video reference or photo reference, and so you're adjusting the poses and trying to get something that feels natural and believable. And that process can literally take hours. And so with MotionMaker, the idea is that you really just set a target, and it takes care of all the rest. The character, starts at a standstill and naturally moves into a walk, naturally moves into a run, can turn its attention in different directions, and that sort of thing. So all of that is generative in that sense, other than the user just setting the path of travel and the direction of attention. So let's jump in a little. There's another example of it. So kind of setting motion on a path. And MotionMaker was trained on a large set of motion, and it has learned how the character moves. It's not doing sort of a game engine style clip blending or state machine that is in use in some cases. This is really learned behavior, and so it knows that the dog turns its head before it turns its body. It knows when it needs to counterbalance with its tail. So in addition to locomotion, you can also add action. So in that example, we were just showing a jump action. So that was in the training set, and then the animator can kind of key those specific actions. So if you wanted to art direct that performance further, we have some controls that I'm going to talk about in terms of the initial generation, but you can also use animation layers. And so this is a common workflow where you might layer on some additional performance on top of the generative system. And you can do that non-destructively. So you could regenerate the AI layer beneath and preserve your hand animated edits on top of that. Of course, if you drastically change the path or something, then the edits you made on top of that may or may not make sense. But if you're just tweaking things, tweaking time a little bit, then you can do that non-destructively. Okay, so let's talk about some of the other controls on the initial generation. So of course, we support characters of different scale. So if you have a character with short legs, of course, they'll need to use a faster locomotion method to move the same distance as a taller character would. We also introduced motion scaling, which is different than your character scaling. So this makes a character feel heavier, like a giant, if you will. So they move a bit slower, and then they have to use a faster locomotion method, also slowed down to cover the same ground. So that's a keyable attribute. So you can an animator can turn that on or off, or they can turn it on or off for a particular part of the scene. So now let's look at path modes. So we have three different path modes to choose from. The first one I'm going to cover is the most restrictive. So if you need a character to be on a particular path and be on time, the time that you've set, then you can set that, and it will adhere to it. Now the motion won't be quite as natural; it'll be a little forced in some areas, and so you might compromise that in terms of getting the location and time accurately. You can let the character just drift in time. So that's just snap location. And that allows, and Etienne's going to go into more of these and how it works under the hood. But that lets the character have a little more natural motion in terms of timing, sacrificing timing. And then we have free, which is the most natural movement of all. The character can kind of freestyle away from the path and the timing a little bit, and you'll get much more natural motion out of that. So those are all under artistic control, and like I said, they're keyable attributes, so you can change them over time. So one more look at that, all of them compared together, you can see the results. Okay, so you'll notice in that last one that the top one where it was snapping time, the character kind of ran faster than would be normally plausible. So that's the speed ramping feature. So on the top, with it disabled, the character will lag behind if it doesn't have a locomotion to go that fast. And in the lower one, we sort of artificially speed the character up to hit those paths. So this feature is out. This is was commercial since June, early June of this year. So it's been out for a couple months, and we're starting to see people use it in novel ways. So they're taking the dog motion in this case and retargeting it onto other characters, which is pretty fun to see. So a lot of that out there. And so let's talk a little bit more about what was released. So we released three trained models. So we have a biped, and within the biped, you have a female and a male style, and then we have a quadruped. So we have our trained dog character. And this is free for anyone to use those characters for any purpose. Autodesk is trying to be very careful about AI and data. So we have the rights to that data. And so we're giving that away. And then you have your interface to compose the motion and actions. Version 2 is in development right now. And this allows you to retrain those existing biped and quadruped models with your own data. And I think this is where it gets really exciting for a lot of people. So if you have, a Buzz Lightyear character animation, then you could, apply that style of motion to the training set of the biped. And then when you generate motion, you'll have motion in that style of the training set. So I'm super excited about that. And that'll include a separate interface to train these models. And I want to assure everyone that all the training is local. This data doesn't come back to Autodesk, and we grow a model, an AI model, with your data. So it's not that at all. You train it locally with your own data, and that never comes back to Autodesk. That could make its way into other customers' hands. So being very careful about that. So just a little teaser about what's coming next as well is we just did this horse capture shoot, and if all goes well, and again under all that safe harbor disclaimers at the beginning, then this is something that we're looking at augmenting the system with a horse model. So that'll be really fun when that matures. Okay, so that's just a look at what's coming. And I just kind of want to touch on this one more time because this really is super important to Autodesk, is we're trying to be completely transparent about the data that we're using to train with and where it comes from. So we bought the AI rights from the actors, commissioned this capture shoot, the AI rights from the dog handlers and so forth. The dogs couldn't sign the paperwork with their paws, so we had to get someone to sign on their behalf. But it's all on the up and up, and not harvesting data from other sources that we don't have permission to. So you can see these AI transparency cards on that URL below for not just MotionMaker, but for all of our AI projects. You can see, the type of model we're using and just more information about the AI system. So with that, I am now going to hand it off to my colleague Etienne to talk a little bit more about MotionMaker under the hood, how it works.
Thanks, Lance. So now let's have a closer look at how MotionMaker works under the hood. First of all, let's have a look at how traditionally you would shoot some animation using motion capture. So traditionally, what you would have would be a director directing some actors, telling them to do actions, do some walk cycles, run to certain directions, shoot all of that motion using different actors. And then when you have the keyframe animation that corresponding to that shot, you would be retargeting from the actor character to the target character, which would be your final character. So for example, if you were animating Buzz Lightyear, you would be retargeting the motion from the actor to your Buzz Lightyear character. Now, if you would be using MotionMaker, what you would be doing would be taking all of the animation that was motion captured, train an ML model on it, use a system to generate motion. The animator would be in the seat of the director. He would be giving the system paths for the character to move on and action and timing for the character to execute. There would be some post-processing to adapt and make the animation be polished. All of this would be applied to a standard character, so always the same character. We'll come back to it. Once you have that animation, you would do like you would be doing in a traditional workflow and pipeline. You would be retargeting the animation from the standard character to the target character, for example, again, just like here. But all of this, that's a bit technical, that's a bit complex. The animator wouldn't be seeing most of the system. The only thing you would be seeing would be the user controls that is providing, the path, the action, the timing, and the system. Again, another view to that system, but maybe a more broken into pieces perspective. So we have the ML model that's fed into the system, the user controls that are providing and giving motion for the character, the animated character, the standard character. And then we retarget that animation on the target character. So let's see some of it in action. So that's an example of how an animator would be directing the standard character. So be setting a path, setting an action with the timing, and generate the motion. Simple enough. So with MotionMaker, we're shipping at the moment a biped and a canine with different action styles. For each action style, we have a different ML model. How did we came up with those? How did we train and build and were able to provide those action styles and character? There's the story. So first of all, we're thinking about what type of character would be interesting. So of course, a biped, it's something that users use most of the time. A canine was a good proof of concept that the system could work with any number of legs on a given character. And to do that, we had to train the ML model using source animation. So that's an overview of the different steps we're going to look into. At the first stage, we needed source animation. So we needed to have a database of source animation on which to train the ML model. So we had different actors that were doing some motion that were used and were performing in a motion capture session. So we commissioned a motion capture studio to shoot that animation. Once we had all of the different animation on the different actors, we needed to express that animation on a standard character. One of the limitations of the system is that one ML model can learn motion for only one character. So we needed the concept of a standard character. And before looking into that, let's just see an example of what a source animation clip would be looking like. So we had multiple clips of simple motions like a walk cycle or a simple jump at different speed. So the concept of a standard character. What is a standard character? It's a definition of joint. So we have a joint hierarchy that will be always the same, the character. And then we have some of those joints that we identify and tag for different components of the system. So the ML model is learning the motion and the movement in a certain coordinate space. So that's the body coordinate. So we have joints we identify to compute that space. We have some joints that we identify as the gating joints. So each leg has joints like the foot, for example, that we tag so that the system knows which foot is in contact with the floor and it can learn the different gating of the character. And other joints are tagged for the foot sliding reduction system. So we tag the beginning and the end of the foot and the knee and the upper leg so that we can adjust the foot movement, the leg movement. So once we add the standard character, we're able to express the animation on that single character. So for that, we needed to retarget the source animation on it. So since we're Autodesk, we own HIK. We made our character support the HIK characterization. It enabled us to retarget the animation. But we know that this system could be used eventually by different users and studios, which might not be using HIK. So the retargeting part, the retargeting component is fully customizable. And the scenes can be at different FPS. The whole training pipeline has been made frame rate aware, so it's managing the different ones so that this model always learns at a given frame rate. You can see the same original animation that we had. We retargeted it on the standard character. So you can see the robot, which is using the standard character definition of the Autodesk biped, can be animated using the same source motion. When we had all of the animation on the standard character, we needed a way to identify the different actions and their timing. So we came up with the concept of action style. We had one ML model per action style, so we can train for standard motion for one action style, but maybe be doing the same eventually for zombie animation. And within an action style, we can define different actions, can have a list of different actions that the character can perform. So for example, the dog can jump, sit, lie, or simply walk in a different motion. And a given standard character can have different styles. So again, or the Autodesk biped is shipping with the male action style and the female action style. When you have the data, the source animation, how to be targeted, what we need to tag, and we have the action styles in our hand, we need to tag the different action with their timing in the data set. So we can do that using the editor. Once all of the source animation has been tagged, we can export the features So the ML model is using the position, direction, velocities of the joints, but also of the whole character at different position on the path. So we use once again the future, once again in the past for the path where we sample the position of the character. Then we extract those features along the actions that were labeled. Once we have that, we use standard libraries for machine learning. So last year with Maya, we shipped the ML Deformer, which was the first ML-enabled features in Maya, which is using PyTorch for training and ONNX for inferencing. So for MotionMaker, we're using the same toolset. So that's it for the training pipeline. So that's simply a recap what we need to do, what you need to do if you were training your own data. You'd be shooting a bunch of source animation. It could be mocap data, but it could also be manual keyframe animation. You need to retarget on a standard character, which you would have defined beforehand. Once all of that animation is targeted on the standard character, we need to do the tagging so we know which action's happening at which time in the training set. Once all of the animation has been tagged, you can export the features, train the model on them, and have our ML models that are corresponding to each of the action styles. So that's cool. Once you have that, we're able to generate motion. And what's really nice with MotionMaker is that it's really simple to do small adjustments. So if you generate some motion and you want to do maybe some change in the timing or maybe insert an action at a given time, it's really simple to start from the existing motion, add some tags, or exit the user path, and generate again. One character is jumping instead of running it at this moment. I've mentioned previously that a given character can have different action style. So we can see the comparison between male and female. So what we did to achieve that is that we took all of the motion we shot using male actors, and we trained one model on that data set. And then we did the same with the female actors. So that made us have two different action styles and can see the motion is slightly different. And since a standard character can have different styles, we can also transition from one style to the other. So using the MotionMaker editor, you can have one action style, then transition to the other one. It's not exactly a transition. It's that the model can start from any given pose and generate motion from this pose. Not only the pose, but also the path that the character has covered once again in the past. So it's taking that information, it can generate starting from this. The system is offering a foot sliding reduction system at the end. So one of the drawbacks of using ML is that ML is always an approximation of what it has learned. So this approximation can introduce some slight foot sliding. So the system can optionally adjust the movement of the feet as a post-processing step. So if you generate some motion, you enable that. You can see when it's off on the left, when it's on the right. It can detect when the feet are in contact with the floor, and using IK, it's adjusting the position of the joints on the legs. You might have seen something similar previously if you are Golem users. So last year we acquired Autodesk acquired Golem, so we took inspiration of the work that they did to reduce the foot contact, to reduce the foot sliding. It's possible that your target character won't be of the same height as the standard character. So in this case, you can simply scale the character using MotionMaker's character scale. If it's a small difference, or if the world is simply larger than the world of the standard character, that might be good enough. But if you're animating a giant or maybe a miniature character, you'll be losing some of the momentum if you simply scale the character. So a parameter that we're introducing is the motion scale, with this, we're adjusting the time that the ML model has to generate motion. So what we're doing, we're generating more frames and then resampling those frames, more or less frames, and resampling the frames generation in time. And since the motion scale is based on acceleration, we're actually using the square root of that. But on the user-facing settings, they are on the same scale as the character scale. So you can have a character that's would be 3 times larger, but the motion scale will also be 3 times. So that's easy to set and synchronize. Like to give you an idea of what it could be used like in real life, it'd be like the giants in the Gilliam's movies. And that's not the only feature that's relying on resampling of the timing of the animation. We also have a feature where we can the adaptive speed ramping, where we can detect if a character is getting behind the path controller. So when it's detected, we can allow the system more time for the character to catch up. So we generate more frames of animation. And then since we don't actually have that time, we'll be resampling the generated animation in time. So to create a motion of the character that will still be natural, but moving faster. And that feature can, again, detect automatically when it needs to ramp up the speed of the character. And it's doing it in a smooth way. Thank you.